we've examined some of the advantages of arrays over regular variables. We also looked at how arrays differ than regular variables in terms of storing them in memory. We group those values together in memory so that we can take full advantage, right, of all those features that arrays have to offer. So if we're going to actually use these arrays, we have to learn some syntax and a few key aspects that all arrays have in common. Number one is that they're fixed in size. So once you declare the size of the array, you cannot change it. Another key feature is that they're indexed, meaning the values in the array have a numeric location. So rather than the first value being index equal to 1, unfortunately with arrays, we'd use zero-based indexing. That means we start counting at 0. That's going to take a while for our heads to wrap around, right? We're going to make mistakes constantly because we're not used to counting, starting at 0. But we'll get used to it the more we use arrays. So the indexing is similar to houses on a street, right? They each have an address. And remember, because we put the values together in a row, it's really easy to find the location or calculate the location of the next address. So yeah, that's what makes arrays possible, right? That's what makes storing multiple values possible. And of course, arrays, they all have to have the same data type in terms of their values. So you can't mix different types in an array. They all have to have the same data type. All right, so syntax for declaring an array. So if you want to declare an array, you're going to indicate the type. So for example, it could be int, right? And then an array name, just like we have variable names. So you might call it like days of the week array, right? If you were storing strings. If it was the scores example that we've been using throughout, it'd be like test scores, right? It could be a good name for that array, or test score array if we want to be really explicit. We use the new keyword because under the hood, arrays are treated as objects. Remember, if we want to construct new objects, we have to use a new keyword. Again, we'll indicate the type one more time. So if it's int, we'll type in int again. And then we use the square brackets. And here's where we put the size. We put in whole number, right? An integer value. So if I want an array of size 5, I just put a 5. So that'll have 5 elements. That's the maximum it'll be able to hold. If I want to give more wiggle room, right, I could go 10, I could go 100. It's really up to me. Just know when you declare the size, right, it's fixed. You can't change it. And then one more thing to note is you don't have to initialize the array, right? You could always end the statement just by declaring the variable name or the array name, I should say. And then you could assign it later, right? Just like with any variable. The thing that's really new here is the ends, right? The beginning and the end of the array. So we're going to be using these square brackets a lot now that we're working with arrays. And then we're going to have to indicate the type, right, before those brackets. So yeah, that's how you declare an array of whatever size you want, right? You decide the size. You could even put a variable in there, right? Let's say you had a constant like num, or we'll say max elements or something. Max elements. You could always put that directly inside the declaration, as long as max elements is an integer. For size, you cannot use decimal values. That doesn't make sense, right? You can't have a size of, a fractional amount. It has to be whole numbers. So that's declaring an array. So again, type, name, size. That's what you need. So this will declare an empty array. So those there'll be spots, right, in the array. For example, if I said array of size 5, there'll be 5 spots in the array, 5 little blocks of memory. So if I drew it right, I can cut it into 5, 1, 2, 3, 4, 5. So that's an array of size 5, right? Now, when I declare an empty array, what's inside, you know, those locations, those memory locations? Is it like empty? Is there something there? It turns out there is something there when you declare an empty array. So we haven't actually assigned any values to this array. So here, let's take a look at an example before we look at the default values of empty arrays. But here's an example of declaring an integer array named scores size 5. Integer array, the brackets here, square brackets tell us it's an array. Scores is the name of the array. You can think of it as a regular variable, right? We're storing the array in the scores variable. And then we're using the new keyword just like we use for other objects. And then again, type brackets, but then always you got to put the size there when you're declaring an empty array. So you don't always have to create an empty array. We'll get to like default values in a sec. Here is default values. So we'll talk about what's actually inside an array when you don't assign any values. Before we get there, we're gonna go through all the different ways of declaring or initializing arrays. So this one initializes the array, but it's empty. Sometimes you already know the values ahead of time. So this is where you can use this syntax. So if you already know the values you want to store in the array, you can use a curly brace on the right side and then list the values. So yeah, use commas to separate the values. Use curly braces on the right side to wrap the values. Notice the left side is the same as before. Type, square brackets, array name. Okay, so that's when you know the values ahead of time. Let's take a look at an example. So if you already know what scores are in the array, the scores array, then you can define them, right? Initialize them here. So those 5 spots won't be empty, right? They won't have default values like we'll discuss in a sec. They're going to have these values right from the start. So 90, this is index 0, 85, this is index 1, 78, index 2, 92, index 3, 88, index 4. Notice the index is always 1 below, like that natural numbering, the natural order that we think in our head. So first element has index 0, second element has index 1, third element has index 2, and so forth, right? And notice the last element, this is an array of size 5 because it's always 1 less. The last element is actually the length of the array minus 1, where the length here would be 5, right? So the fifth element has an index of 4. We're going to bring that up a few times in this section of the lesson because the end of the array is really important. We'll talk about why. So yeah, contiguous memory in arrays. As we mentioned before, right, the array stores the following integer values in order in memory. So in memory, these values would be in a row, in a continuous block. Remember, if we go way back here, an array of 5, right, would have 5 continuous blocks. We could do one more block there. Let me fix that. Maybe make it purple, right, just to match. But yeah, essentially, arrays, they store these values continuously in a row or contiguously, right? That new vocab word. All right, let's go back to where we were at. So organizing data contiguously like this is what makes accessing elements in arrays so fast. So how do we actually access the elements, right? Before we, oh yeah, this is actually this slide. So to access values in an array, you use the name of the array and the index of the element. So say you declared this array over here, right? You already have the values in there. You have all your spots set up, right? The 5 spots, 1, 2, 3, 4, 5. What if you actually want to see what's in the first spot or the second spot or the third spot? How do you actually grab these values, right, from the array so that you can use them? Well, you just need name and index. Remember, arrays use zero-based indexing, so the first element has an index of 0. The second value or element, I should change that to say element. Element has an index of 1. And then just to kind of create a general rule, any nth element has an index of n minus 1. So the 100th element would have an index of 99. The 1 millionth element, right? Let's say we had an array of size 1 million. Well, the last element in the array um, would be 999, 1,999. So this means that the last value of an array is L minus 1, where L is the length of the array. So here's the syntax for accessing elements. You just use the array name, indicate the index. So here's an example, right? Let's say we wanted to print out the scores. We didn't print out all the scores. There's a missing system.out here for the last score, right? It'd be scores 4. I might change that just for clarity. But yeah, we're printing out the first 4 scores at least in this example. And the way we print out the scores individually is just by using the name of the array and indicating the index we want. So this would print out 90, 85, 78, and then 92. And if I did scores index 4, that would be 88, of course. Yeah, I'll definitely change that example for the slides. But yeah, simple as that. Not too crazy. You can throw it around wherever you want. You could assign it to a variable, or you could just directly invoke it right here, like we did in the print method. So, like I said, this is for declaring empty arrays. This is for declaring or initializing arrays with the values ahead of time. So what do empty arrays look like, right? Before you actually give it values. It turns out Java will use default values depending on the type of the array. So if I did int scores equals new int 5, this is an empty array. We declared an empty array because we haven't actually told the array which values we want in those 5 spots. Well, it turns out by default, int arrays will just have zeros in each spot. So again, if I had my blocks of memory, 1, 2, 3, 4, 5, there'd just be a bunch of zeros in my array of size 5 if I don't initialize it, right, with some values. So empty arrays, empty integer arrays will just have zeros. Empty double arrays will have a bunch of 0.0s. Empty Boolean arrays by default will have false values. And then string arrays or other object arrays, basically anything that's not a primitive, right, is an object, will have this value called null. So what is null exactly? What do I mean by null? So null is a special literal that represents the absence of a value or reference in Java. So it means that that particular variable or object isn't actually pointing to anything. So there's nothing there. So null is, think of it as a synonym for nothing in Java. All right, so yeah, that's empty arrays. So we talked about what an empty array looks like. Well, what happens if we try to access an index that's not valid? Because remember, arrays have an index between 0 and L minus 1, where L is the size of the array. So for my, array of size 5, I only have a few valid indices or indexes, right? The plural of index is indices. I can make that look a little bit better. There we go. So I have my 5 spots, right, in my array of size 5. So that means this has an index of 0, index of 1, index of 2, index of 3, index of 4. And remember, if I declared an empty array, right, if I did new int, and then I said the size was 5 on the right side of my declaration, then this would just be a bunch of zeros inside. And of course, this is the first element, the second element, the third, the fourth, the fifth. Again, confusing because the index doesn't line up right with our natural ordering. But yeah, this array has bounds between 0 and 5 minus 1, which is 4. L minus 1 is 4. So trying to access an index value outside of these bounds will trigger an error. So let's say I try to do scores, right? Remember that scores array was only 5 long? What if I try to do scores 5? Remember, 5 is the 6th element. There's no 6th element in my scores array. Or if I did scores 6 or scores 100, that's definitely not between 0 and 4. That's outside the bounds. So what happens is Java will trigger a runtime error. It's a special error called the array index out of bounds exception. You left the bounds, the boundaries that array allowed for the indices, for the indexes, right? Remember, indexes is not a word, it's indices. So yeah, do not try to access an index that is invalid because it will trigger an error. This happens a lot when you're first working with arrays because you'll see an array of size 5 and you'll be like, oh yeah, let me access the 5th element by doing, scores 5. Oh, but you forgot 5 in an array of index of 5 in an array of size 5 is invalid. It doesn't work. So check it out in this example, right? We have an array of size 3. We try to access the 6th element. It's going to throw an exception. That's just not possible in this array. So you're going to see this one maybe quite a bit when you're just getting started. Just keep an eye out. Be careful with your array bounds. Remember, they should only be between 0 and L minus 1, where L is the size of the array. We use L because L is length. You'll notice once we get to some of the later slides why length is the preferred word. All right, so next up is going to be modifying elements. So modifying elements in an array, you're going to use the same information as accessing them. The only difference is you're going to have some assignment on the right side. So this looks exactly like accessing elements. This left side is everything from our previous slide. But let's say you want to change the value in that index, right? You just do an assignment operator with the new value. So name of the array, index, new value. Name of the array, index equals new value. Basically the same as accessing elements, but with an assignment on the right. And just like with variables, right, make sure that if you're going to assign that array element a new value, it's still got to match up in the type, right? You can't be mixing and matching types with arrays. So yeah, int array can only take int values, string array can only take string values, etc. So check out this one. In this example, we initialize an empty array, integer array, and then we modify each value using the array name index equals new value syntax. So there we go. So rather than assigning them up front, right, with the curly braces, where we could just list 90, 85, and so forth, we do it individually here by using that modifying syntax, which is the same as the access syntax. So that's modifying elements, looks exactly like accessing them, just with an assignment.